Good morning, all. Welcome to another session of data analytics. We quickly pick up where we left off last session. Activity 3 was the last thing we discussed. It asked us to get the output of the neural network we built and trained for the same input used to train it. And we did it. But the results we got were not 0 and 1. Instead, they were some other numbers between 0 and 1. And after that, we started discussing why it is the fact, and we concluded that session with the point that the output layer no matter what inputs are, because of the standard logistic function, this is the function, all the outputs that comes out of this would be in the range of 0 and 1. So we need to think of a strategy, because now it's not possible to, for example, if you get 25, if you get 66, because these things were the output. Let me show you the output. Another time. Okay, these are the outputs that you see here. Okay, now which one means admit and which one means not admitted? Here you need to, as the data analyzer, you have the authority to decide about that. We talked about being strict in decision making or being lenient last semester. But here that we have, for example, 0.65. When it is 0.65, do you think it would be better to consider this as 1 or as 0? I'm waiting for your answer. 1. The next one is 0.20. 1 or 0? So you got the point. You just need to categorize these things you see in front of you the way you want it. So in fact, when you have your neural, by the way, I received an inquiry from a student that he said his numbers are different from the numbers that showed up on my computer. Of course it is different, because your neural network is different from my neural network, because the training data you have is different from the training data that I have. All of those things are different, and don't worry about that. But the general outcomes must be similar. That I will tell you about those things that you can check your work with them soon. Okay, 13, where's the other one? So in fact, here, when you get the output in such a thing, that it is the middle, if you get the output in this range, you will substitute them with 0. And if you get the output from here, you will substitute them with 1. So you see, you need to add another phase to your neural network to get the results that you want. So the neural network that you make with R is not finished, is not complete until you make this final step. Let's make it. But before that, we need to learn another command in R, if else. Again, because of the fact that you are quite good with R, these things are like a piece of cake for you. The syntax is this. You put if else in the R. And after that, you put test expressions. For example, you put the test expression x equal to 0, for example. You put only the expression, the test expression. Do you remember, for example, we had for loop, we started with something integer, and after that here we had the test expression. And after that we had I++. So when it is test expression, you just need to put something that you are telling R to test it. For example, if x equal to 0. And what happens here? If the answer, if the result is true, get x. Let's make it x1, so they are not confused. x1, and if it is false, it is y. That you can see here. To make sure you have a good understanding of this function, just check it another time. If else, test expression. If it is correct, do x. If it is not correct, do y. Okay. A couple of helpful signs for R that we usually use them for. If else. This is the remainder. The same way we had it with Java. It divides the number in front by the number in the back of it as many times as it can and returns the leftover value, the remainder. It is just calculated in a simple way. It calculates the remainder. I agree, the explanation should be much better. But since it is a standard explanation, I put it here. And another one is this one. It checks whether two objects are equal or not. So do this activity. Write a code in R that checks if each element of this vector is even or odd. Before you start, let me tell you something. Remember, my friends, one of the good things about R, you don't need to define for loop, because R automatically consider everything as a for loop. So when you give this vector to a command, it consider everything as a for loop. The output also considered as vector. Okay, start, and while you are doing it, I'm doing it also on R. You can check your work. Okay, as you can see in the slides in front of you, and most probably you have done it yourself as well, you put if else. Okay, what is the test command? You want to check each of these numbers 5, 7 to 9 if they remain there over 2 equals to 1 or not. Since R automatically consider this as a for loop, because when you put a vector somewhere, it considers this it like this. First do it for 5, then goes and does it with 7, then 2 and 9. And it says if it is 0, if it is yes, the remainder is 0, print out even. As I told you, in R, we don't have any printing command. As soon as you write something, it means that print it. If it is variable, it would print it. If it is a string, it would print it. So when you put in quotation mark even, it means print even. And when you have in quotation mark R, it means print out. Okay, now we are close to the main activity. We needed this one for doing it. Okay, another thing, we have talked about these things. Prediction, precision. The number of correct predictions and the total number of observations. Now for this last thing that I ask you to calculate the outputs of your neural network for the same data you used to train your neural network. What percentage of, in sampling, what percentage we considered? 80%. And what was the number of the selected data? If I'm right, it is 200, it was 321. So the total number of observations is 321. And now we just need to check how many of them are correct, number of correct predictions. If it has predicted 0 prediction, we need to check if in reality it is 0 as well. If it is 1, we need to check if in reality it is 1 as well. But if you have predict something as 0, but it is 1 in reality, that's bad. If you have predicted something as 1, but it is 0 in reality, it is as bad. So activity 5. According to the output you got from your neural network and the original data you have with binary.csv, calculate how much your neural network is accurate with its prediction. My friends, you need to do these two things. Let's do it first, check it together. First, you need to convert the output, the neural network outputs, into final format. It is still not finalized. You need to finalize it with another line of code and tell if the output is greater than 5, greater or equal, make it 1, or if it is smaller than 5, make it 0. When you make it, you should get such a thing. 0, for example, 0, 1, and 0. And also you need to get the admit column of the training data that you have. For example, it is 0, 1, 1, 0. And after that, check if these two things are equal, count it. Otherwise, don't count it. And finally, get how many correct predictions. Go ahead. It takes time. Take your time. If you have any question, ask. First, convert your neural network. It is not the last activity of today. So try your best to finish it as soon as possible. And if you have any question, ask. First of all, you get the output, the way we had it last session together. Check how many rows does it have. It should be around or very close to 320. After that, convert it to another vector of the same size that includes only 0 and 1. As you can see in the R presentation in front of you, the output is O. The number of rows is 321. Now I convert it to O1. As you can see in this R presentation in front of you, O1 equals if else, and it says the check statement, the test statement is O greater than or equal to 0.5. If it is yes, put 1, otherwise put 0. So in this way, you get O1. Now it is finalized. So you can see, oh, there are many zeros. There are many zeros. And now I leave it to you to find a method, to find the code by R to calculate how many predictions have been correct. Trial and error. You have noticed from Java experience how much it is important, practice. Knowing commands is not enough to be able to be fluent with a programming language. Now all the codes are available on Google, but we need to know how to use them. So be patient with the experience, with the tries. You offer the challenge. Okay, let's review the code together. What we are supposed to do here, we want to calculate how successful, how accurate we have been regarding their predictions. Where are the predictions? The predictions are not the neural network raw outputs. So we apply an if-else statement over them and we make them ready to use. As you can see in front of you, this in this R. O1 equal if-else, if it is greater than 0.5, it is 1, otherwise it is 0. Great. But after that, we need to get also the part that we want to compare the results with. What's that? It is the admit column of the training data we have. Be sure that you are using the same data, that during all the process, the data must be the same. So from that training data that you used, you get the admit column by this $, and you get t-admit. T-admit T-admit. Where is it? It is not here. So let's make it here. View and T-admit. Admit. As you can see here, they all are 1110 because they are the original data that we had, but we use these things for the training data. Okay, now we have these things, and now we want to compare these two things. One is T-admit, and the other one is O1. So when we want to do this, again, we need that if-else statement. And we want to put the results in another vector that we call it P. So if else T-admit is equal to O1. If these two things are equal, put 1, otherwise put 0. So when we run it, we get another 0, 1 value. But this 0, 1 that you see are in fact, it says, for example, the 288 prediction is 0, wrong. 289 prediction is correct. So when I sum up all the numbers in P, it is the total number of correct predictions. And what is the accuracy of this prediction so far? 233 over 321, 72%. Pay attention, my friends. When you use exactly the same data that you use to train your neural network, the accuracy rate is 72%. So you see, it is not very ideal. So quickly we cannot claim finishing structuring our neural network. Hopefully we are going to have very enjoyable homework this time together. So you are going to experience all these things in a more practical way. Okay, now I want you to, according to the algorithm that I just introduced to you, calculate your prediction accuracy. And you will see all of them are around the same thing. So although everything is random and your neural network is different from mine in terms of weights, but the structure are the same because we all apply similar structures, the accuracy would be the same. Okay, go ahead and calculate your own accuracy. Make sure you put the correct number of training data. For my case, it was 321. For your case, you need to calculate it, but it must be around 320. If it is far from this point, okay, some mistakes should be over there. And when you got yours, let me know. What did you get? I got 75.4. Oh, you got better number than me. Okay. Now we are good to go to the next topic. Okay, you built your neural network, you ran it, you checked also the performance. But let's go for some more professional way of doing these things, because R is an very specifically designed for a statistical use. So of course, it has some already available commands for doing all these comparisons. But that was a good point that you did it yourself in the previous set of slides. Okay, before we go ahead, let's do a review on the concept of frequency tables. Frequency tables, we discussed it together last semester, and you see, when I lectured last semester, I mentioned it many times that all the things that we discussed this semester, sometimes theoretical, but they are the base of solid body of data analytics knowledge. When you have a good understanding of especially that two first chapters of the textbook, it would be much more understandable, the remaining parts of the books. Okay, here it is an example of a frequency table because you are familiar with the concept. So I decided to bring up just an example. And in our case, it would be a good example. It would be a customized example. See, my friends, you have some predictions, and so you have a reality things, okay? And the predictions are to predict something as 0 or 1, and reality is to, they are either type of 0 or 1. What is N1? What is N1 plus N2 plus N3 plus N4? It's the total prediction, total number of predictions. What is N1 plus N4? What is that? Very good. And we have talked about these things before. So N1 plus N4 is the total number of correct predictions. And like that, you can go and see what does N2 mean, what does N3 means. N2 means the number of wrong 0 predictions. We put 0 for 1 cases. Okay, so if there is a command in R, that is there such a thing, that can generate for us a frequency table, that would be great. So to build an frequency table, an efficient way of doing it is doing such a thing that you see, an efficient approach to build a frequency table. We create a column for real, and you have to use it for the next activity. You create a column for reality, and you create a column for predictions. So when you see such a thing, you put it on. When it is 0, 0, it belongs to N1 category. So quickly you put it N1, no, N1, N1, and like that. When it is 1, 1, it belongs to N4. belongs to N4 and like that. So with that, you can create all those things, but it talks about an efficient approach to build that things, and R also does the same thing. And so when you want to create a frequency table in R, syntax would be such a thing. The syntax you see here is a customized one, so you can understand it. Okay, just this table is shouldn't be capital. It is small. Oh, I created a very good small table now. So don't forget that it's just a mistake here. It should be, it must be small. Okay, it is the data frame that you have. For example, the training data. You get the reality from this. In our, the things that we did, we had training data, I guess. For the training data that we had, what does it mean? What is the reality? What came after this dollar? What was reality? The admit column. Thank you so much. So you put the data. So in fact, you get that column very easily, because I told you R is designed to be the simplest possible. So they applied also the same approach. So the data frame that you have, the training set you have, and you get the reality column. What is reality column? It means that reality, real and correct things that you use to train your neural network. And here in our case, it is admit. Another thing, data.frame prediction. What was that? In our case, it was output, if you remember, dot what? Net results, if you remember, we used it. And now when you go and check your neural network and how you get the output of your neural network, it is exactly the same thing. You get the output of the neural network, because output is something that R knows by default. And you get, but not the neurons column. You get the net results column. And when you get this, you get the answer. So let's go for this activity. Create the frequency table of the data you have on the right. You don't need to retype the data. It is editable. So if you are still, you didn't download the file, download it on Canvas, from Canvas, and you get this data. Where do you need to put this data? You need to put it on CSV, because we have talked about it. CSV is the most efficient structure we can use with R. And also, if you remember, also we use CSV for Java. But with R, it's even much better. So you create that things, you get the data, and you apply the command that we just talked about. Okay, go ahead. Take your time, and remember, you're all learning the language. It is not about that, oh, very good, now I just learned this command. Command is just 10% of the teaching, 5%. The rest is your ability to manipulate, to work with all those things. When you learn a command, it is exactly like you are learning a book about bicycle riding. But you need to ride it, you need to go on the streets, you need to try it, practice until you learn how to ride a bicycle. By reading a book, it's not possible to become a bicycle rider. So take your time, no rush, until you make your own first frequency table. First of all, create the CSV file. After that, import it into your R console. And after that, they get the reality and get the prediction. Okay, my friends, let's do it together. First, I'm going to show you the CSV file that we created. Here you see the CSV file. When you have the CSV file, according to the things that we discussed together, you read that CSV file into your R file. And here is the command. And I want to put it N1. N1 read CSV, choose the command to get it. And I import it. The reason, because I canceled it, because I already have it. And after that, when you get your R, when you get your file presented, now you are ready for the rest. Check about the N if it is available. Let's check it here. You see N is here. And when I run it, it is the reality and prediction. So if you put N1 dollar reality, you get the first column. And if you put N1 dollar prediction, you get the other one. So just quickly put the command here, command for the table. I want to put it in another table named TA. Table is the command for creating the frequency table, and see how much frequency tables are important that the name R has assigned to it is table. So, and reality, the first column and the second column. And when you run it, you get the answer, TA, and it is the outcome. Okay, now we have only 1 minute to the end of this session. Any question? So because I don't want next session, we again start reviewing on something. So just finish this activity too before we finish it. Because see, my friends, when you see stuff on the R, here there is no explanation which one is real and which one is prediction. Do you agree? But always the first point, the first part that you put is real. Yeah, I mean, when you put here and one, the first element is always the real prediction. The other one is the prediction. So in the next one, just gives you, in the next activity, just gives you a hint on how you can titles are on those things. So it says run everything again with R0, R1, as you can see now in this activity 2. It says run everything with this one and check the results. You will see very easily you can add some sort of title over your frequency tables. So do it, and I'm going to run it for you also in R. You can check your answer with that. So you just need to create another CSV file. Here I have named it and2, as you can see, and2. Reality and prediction, and everything is the same. That makes the name also TA1. No, TA1, yeah, to make it different. So and2 and 2 again, prediction. And let's see what is TA1. So you see, you got the better type of referencing. Oh, I didn't share it still. So here is the code. And 2, it is here. And TA, you get the table the way you see in front of you. And here you see the better titling. Thank you so much. Have a wonderful rest of your day.